Okay, we are getting ready to review our chapter in decimals. So you should have your chapter 13 review out, page 321. Have it out and in front of you. And I'm going to speed through some of these sections so that you know what it is that you are to do. And then I want you to work on this review. So in the top part, 1 through 8, we are comparing. Okay? Bigger, smaller, equal. Remember, the key with decimals is that I can add zeros to the back to make them the exact same size so that I can compare well. The longer decimal does not mean bigger because I can add zeros. But when you add zeros, it's easy to compare. Okay? So first of all, let's look at the whole number. This is 2 with a decimal behind the 2, which means the whole number is a 2. Here, there's no decimal, which means the whole number is a 29. So that's pretty obvious, right? That the bigger one is 29. Now here I have a 6.7 and a 6.70. Can I add a 0 to the back of this number? Absolutely, and that makes them equal. Okay, let's add a 0 to the back of this number to make them the same. Now, look at the whole number that's behind the 3. This one is 109, but after adding a 0, this one is 190. So which one's bigger? This one. Okay, 8.25, 8.5, and we're going to add a 0 so that we can look at them at the same length. So this one has a 25, this one now has a 50. What's bigger? 50. All right, this is 52 in front, and this is 5. Well, all I have to do is look at the whole number to tell me that one is bigger. Now, look at number 6 first. See if you can answer it. Look behind the 7. This one has a 2, 9. This one has a 3. I'm going to add a 0 so that they're the same length. And then I'm going to look at the number behind the decimal. That one's 29. That one's 30. That's bigger. Okay, look at the number in front of the decimal. That's a 40. That's a 4. 40. Okay, 2.09, 2.090. Can I add a 0 to the back of this to make them the same? Yes, and then they will be exactly the same when I add that 0. So don't forget about those zeros at the end. Before I even order these decimals, I want to make sure they look the same to me and they're the same size so that I can compare them well. Okay? So I could even put 2 decimals behind, or 2 zeros behind that decimal. So look at the whole numbers first. We've got a 56, 56, 57, 56. So automatically I know that this one is going to be the biggest, right? So 57.1 is going to go at the end. This is a 56 with nothing behind it, so that means that it is going to be the smallest because it has no parts to it to make it any bigger. This is 0.80 and this is 0.83. Well, 0.83 is bigger, right? So it's going to go here, and then that one with the 8 is going to go here. Okay, now what about this side? Now this one, all you have to do, look at the number directly behind the decimal. Okay? You want the one that is the biggest. There's a 0, there's a 5, there's a 1, there's a 7. This one is going to be the biggest because it had a 7 in that first place. I don't even have to look at the ones behind it. Next is going to be the 0.5. This has a 1, so next is going to be the 0.15, and then the smallest is going to be the one with the 0 in the tens place. Okay? Now, on the number line, you're just going to fill in. It's going up 1/10 each time. So this is 2.0. This is 2.1 or 2 and 1/10. And then you're going to go up. Because what they do is because they can't fit all these lines together on the bottom, they're going to go back and forth, back and forth. So it's going to be 2.1, and then up here is the next dash. So that's going to be 2.2. The next dash is going to go below 2.3. The next dash is above 2.4. Okay, so do you see you're just alternating up and down looking at where the dash is, and you're going up just 1/10 all the way to 4.0. Okay, now rounding the decimal. We practiced this earlier. If you're rounding to the whole number, you look at this one. Okay, this is your whole number. You look behind it. That's bigger than a 5. So the 7's going to go up to 8, and then everything else drops off. Okay, now I'm going to go back to my original number this time. Now, I'm going to look at the 10th place, which is here. I'm going to look behind the 10th place. That's an 8. So that means my 10th place needs to go up to a 7. Now, I'm doing the 100th place. So I'm looking at the 8. I'm looking behind it. That's a 2. So that means the 8 stays the same. And I'm going to go back to my original number. Okay, and keep the 8 the same. So you're going to do the same thing here for the rest of the chart. Now, 16 through 19, multiplying. The only thing that I want to remind you here is that remember, however many numbers are behind a decimal in your problem is how many numbers need to be behind a decimal in your answer. You do not bring the decimal straight down like in adding and subtracting. Okay, so here, 1, 2, 3, you're going to have 3 numbers behind a decimal. 1, 2, 3. Again, 3 numbers behind a decimal in your answer. 1, 2, 3. 3 numbers. There's no decimal here. 1, 2, 1, 3. Oh, look, they all have 3 numbers behind a decimal in the answer. Okay, the blue bubble is for you to estimate. So 3.5 is closest to 4. 4.7 is closest to 5. So 4 times 5 is 20. So you're going to estimate before you even start to multiply. So that's what you're going to do first. Estimate, then multiply, check to see where your decimal goes. Okay, dividing. This is what we've been doing just recently. So you're going to bring your decimal up and divide like normal. That's it. Remember, if it doesn't go in evenly, you have to add those zeros. You add zeros to the back if it doesn't go in evenly. 24 through 27. Remember, this is how we turn fractions into decimals. The bottom number goes into the top. So here the 4 would go on the outside, the 3 would go on the inside. It's not big enough, so I add a decimal 0. If it doesn't go evenly, and I can tell it's not, you're going to add another 0 and keep dividing until you have no remainder. Okay? So bottom number into the top, add your decimal. Okay? Complete the table. So this is where when we multiply, okay, we're going to move the decimal to the right. On this one, how many places? 2 places. This is division, so the decimal is going to move to the left 1 place because there's 1 0. This is multiplication. That decimal is going to move to the right 1 place because of 1 0. Okay? Then you have 4-word problems. Mr. Torres drives 24.8 miles to work one way. How far does he drive each day? If it's one way there, he's got to drive it back. So we are going to multiply this by 2. And I'm going to let you do the math. How far does Mr. Torres drive in a 5-day work week? So you need to take this, that's 1 day. You need to take the answer from that problem and then multiply it times 5, right? Maggie got an 89.3, a 93.1, and a 78.9 on her math test. What was the average of the 3 tests? Okay, so what are you going to do? You're going to add up all 3 numbers. Then you're going to take that answer and you're going to divide it by 3. That's how you find an average. Okay, so add these up first, then divide that by 3 and you'll find the average. Reagan swam 2.5 laps on Monday, 2.4 on Tuesday, 3.2 on Wednesday. What was his average? Same thing here. You're going to add all the numbers, and there's still only 3. So you're going to add them up first, and then you're going to divide by 3. Okay? Okay, now, in the comments below, to help each other, okay, I want you to start at number 16 and start counting. Okay, so this is 1, so 16 would be Nate's, 17 would be Emma's, 18 would be Leah's, 19 is Nehemiah's. Okay, these are the ones you're answering in the comments. 20 is Kate's, Peter's is 21, Luke, you're 22, D, you're 23, Lily, you're 29, Randy, you're 25, Madison, you're 26, Brooklyn, you're 27, Chase, you're 28, the chart, Caleb, you're 29, the whole chart, Ava, you're the whole chart on 30, Maddox, you're number 31, and Riley, you're going to do 32. Okay, everyone got their numbers? All right, I'll be looking at the comments.